Hi, and welcome to this video on instrument design and selection. In this video, we're going to talk about how to make sure you get quality data from a research project or any other project. So it's quality assurance. Quality assurance, by definition, is a program that's designed to maintain the highest possible data quality in the network or in the measurement system. You want good data, and there are steps to collecting good data. We're going to go through the steps now. There are 6 steps or 6 components of a quality assurance program. They are laboratory calibrations, field intercomparisons, real-time monitoring of the data, documentation, independent review, and the publication of data quality assessment. Laboratory calibrations is where you take your instrument indoors in the laboratory and then calibrate it against a standard. And that way, when you put the instrument out in the field, you'll have confidence that it's ready to make good measurements. But that doesn't always happen. Sometimes between the transportation from the laboratory out into the field, there are some problems. So you do need to check the instruments once they go out in the field again. One way to check the instruments once they're out in the field is to compare similar instruments. If you have anemometers or whatever, thermometers, check them against each other. Are they recording or reporting the same values within the accuracy of the instruments, or are they widely different? So this way you know that you have quality data. The other thing also is you can bring a standard from the laboratory out into the field and then compare the measurements made by that standard to the other instruments to see if they're still within calibration tolerances. Once you start collecting data, you got to monitor the data, and there's a lot of data coming in. So it's difficult to do quality assurance of each element or each part or each measurement. So typically we have software that will scan the data and look for suspect data. Another step in the quality assurance program is documentation, meaning that once the instruments are out in the field, you need to identify the location, the elevation, the type of station, the type of instrument, and then also when you fix an instrument, if it breaks, when you recalibrate it, or if you have to swap out sensors, that should be documented also, so that when you start to see differences in the data, you'll realize that that is the day that you swapped out the instruments. You should have independent reviewers come in and take a look at your program, your quality assurance program, your data, and all your other documentation, so that they can highlight areas that you can improve, or they can give you a thumbs up and you have confidence that your research, your data collection is good. And then finally, what you need to do is to publish your data so that other people, besides just one individual or 2 individuals that come in for outside review, you'll have a whole plethora of people looking at your data, looking at your results, and then they can provide you with suggestions or ideas how to improve, or once again, they can give you the assurance that your data is of good quality. Some other tips with quality assurance and the quality assurance program. You need to make sure that everybody on the program is trained properly, all at the same time, so they know what they're doing, so that when they calibrate the sensors and put them out on the field, you have a good confidence that they are doing the correct calibrations, and hopefully the data that you get will be good. Also, everybody should be following the plan that you set up, a standardized operating plan. Remember that frequently you should go out and recalibrate your instruments in the field to make sure that they are acting or they are still measuring within standards. You should use the same instruments, as many of the same instruments as you can. Remember that instruments are expensive. For example, if you're trying to measure wind, you don't want to use a prop anemometer and then a cup anemometer and a sonic anemometer. You should probably put out all cup anemometers or all sonic anemometers, and hopefully all from the same company. And then you should have a quality assurance plan, of course, that talks about the measurements, the procedural standards that you're going to have. How do you collect the data? How do you average the data? Do you measure the data to the nearest hundredth of a degree Celsius or tenth or just 1 degree Celsius? All these things need to be decided before you go out into the field and start making measurements. And then, of course, you need to back up the data as often as possible. And we talked about documenting all the procedures, problems, replacement of sensors, and all those other things. So those are the basics behind a quality assurance program for a data collection project.